Hello Year 10. So we are looking at a required practical. So this is required by the exam board for us to have done this at school. Obviously we're not at school, so we're going to do it at school for you. You are going to watch us do a live lesson and you are going to write down the method, how to do it, record some results and then do the calculations that accompany it. So first of all, title today is specific heat capacity. And put a note next to it, it is a required practical. So as always, we have a quick couple of starter questions here. So this goes over what we've learned in previous lessons here. So you need to know what equations you need for gravitational potential energy and what you need for kinetic energy. So pause the video and work out your answers. So here are the answers. Remember, always show your workings. Make sure you include the calculation that you've used and obviously use units at the end. If you've got the second question wrong, it is probably because you forgot your bod mass. You need to do your elastic, your E squared, first of all, before you times it by half times by the spring constant. So as I have said, this is a required practical. We are part of the AQA exam board. So this is a necessity to go along with your GCSE exam. So make sure you particularly focus on this kind of lesson. So specific heat capacity, what is it? It is the amount of energy needed to raise the temperature of 1 kilogram of any material. We use metals in school, and it's to raise that temperature by just 1 degree Celsius. So basically, how much energy is needed to increase its temperature? As always with physics, we do have an equation for this. It is energy equals mass times by the specific heat capacity of whatever material that is, and then times it by the temperature. We use this weird symbol here. It's called a theta, and that means a change in temperature. So can you write down a definition and write down the equation? Pause the video so you've got time to do this in your books. So a great skill in physics is to be able to arrange a maths triangle. So first of all, can you put your equation for specific capacity into the maths triangle? And then are you able to actually rearrange it? You can see the levels, the grades here, if you are able to do that. You also have at the side here the symbols that you need, the units that you need for these equations. So we are always going to look at temperature in degrees Celsius, and mass will always be in kilograms. Joules, as always, like we've been doing for the past couple of weeks, will be in energy will be in joules, which is a J, and then our actual specific heat capacity will be joules per kilogram per degrees Celsius. So just make a note of those as well. But see if you can put the equation for specific heat capacity into the triangle. So here is the answer. Obviously energy would go at the top and everything else underneath. If you were looking for the mass of something, you could cover up mass, cover up the M, and it will be energy divided by your heat capacity times by temperature. If we were looking at C, the heat capacity, it would be energy divided by mass times by temperature. And if we were looking at change in temperature, so a theta at the end, you'd cover that up and it would be energy divided by the mass times by the heat capacity. So just make sure you've got that written in your books, and if you want to go that extra step, write down the 3 versions you can get from this triangle. So because we are looking at specific heat capacity, the equation that we need today is C equals energy divided by our mass times by our change in temperature. can you please just make sure you have got that particular equation in your books? So we are going to do this as a live lesson for you on Thursday the 28th. It will be period 2 and 3. So H band will be period 2 and grammar band will be period 3. So what we're going to do, so first of all, we are going to take a block of aluminium and we're going to weigh it and we're going to record the mass. We are then going to place a heater in the hole on top of the block. We're going to connect that to an ammeter and a voltmeter and a power pack. We are then going to put a drop of oil into one of the holes and put a thermometer into it. The oil will allow the thermometer to be in contact with the metal block to actually allow it to record the heat value. We will then switch the power pack on. We will take some readings from the ammeter and voltmeter, and then we will measure the temperature and time, how long it takes to heat up. We will record that temperature for approximately 10 minutes. However, that may be adjusted when we actually do the experiment. We will then record the results in a table. So first of all, I want you to bullet point this method to make it as short and sweet as possible, a list of instructions, if you will. So pause the video and make a list of instructions for our method. So we need to record the results. This is the table that we need to use. So we have time in seconds in the first column. We have work done in joules. That's our energy required. And then we have our temperature that we're going to measure using our thermometer. So now I would like you to draw this table in your book. And then just at the bottom, put a little note there that we need to record the mass of the aluminium block after we've weighed it. Okay, so I've included this just to remind us that when we use equipment in a lab, there are some safety instructions that we need to follow and be careful of. You could get asked this kind of question in a GCSE. So we would always stand up, tuck your chairs in, get your books out the way, goggles on, aprons on. But in this particular experiment, what we need to be careful of is obviously we are using electricity and we are heating up a piece of metal. So actually this piece of metal, this aluminium block, can become incredibly hot. So that is our biggest hazard here. So we need to do it on a heat-proof mat. Be careful, and obviously if we do burn ourselves, we would need to run that underwater immediately. So just a few safety procedures to follow if you were actually doing this experiment yourself. So can you draw this equipment in your book? This is what we will be using. So lots of calculations in this experiment. So the first calculation that you need to write down is power. And power is our current times our voltage. These will be taken from our ammeter and our voltmeter. So P equals I times V. Make sure you've got these calculations written down in your book. Then we will need to work out the work done by the actual heater. This time we're looking at the work done, and that is going to be, it's not going to be force times distance because we're doing a different experiment. It's actually going to be power times by time. So again, write these calculations or equations down in your books, ready for next lesson. So after we've done our live experiment, you will have lots of data that you are then going to plot onto a graph. It is going to have work done at the bottom and temperature at the side. You then will draw a line of best fit, and then you will start calculating the gradient of it. You will then work out the heat capacity and then the specific heat capacity. So on the next slide, you will see the order of the equations that you need to write down. But you might want to just write down a little prompt to yourself of what you're going to do on the graph. So where work done goes and where temperature goes, you might want to just make a little note here of how you actually work out a gradient as well. Down to you how detailed you want your notes to be. So once we have our graph made, obviously we haven't got it at the moment, we're just checking out what we need to do for next lesson. So this is preparation for what's going on next lesson. So if you want to prepare in advance, obviously you can write these down ready to go. So we need to work out our gradient. So that is the change in temperature, and that is divided by the change in work done at the bottom of our graph. You are then going to work out the heat capacity. So the mass of the block, which is going to be around 1 kilogram. We're then going to divide that by our answer for the gradient. And then finally, we're going to work out the specific heat capacity, which is the heat capacity from the previous answer, and then divided by the mass of the block, which again is going to be around about 1 kilogram. Just to note here at the bottom, heat capacity is actually the amount of energy transferred to an object to increase its temperature. When we're looking at specific heat capacity, this is the specific amount of heat needed to raise the temperature up by just 1 degree Celsius. So heat capacity is a rather generalized version of specific heat capacity, which is why it's called that. So that brings us to the end of today's lesson. So we've done all our preparation. We know what we're doing. We've got our method. We've got our calculations. We've got our equations. We are all ready to go. So tomorrow we will actually be doing the live lesson, which will be watching us do the practical. You will then be recording the results. You'll then draw a graph, do the calculations, work out what the specific heat capacity was of the aluminium block, and then you will write your own conclusion. So, well done everyone. See you tomorrow.